Welcome to the course Digital Transformation and Technological Innovation. So, we are into our second module, that is digital infrastructure. So, let us start from where we left in the last session. So, we are talking about operating system and let us continue that part. Now, within operating system there are a number of programs that combine together to form the operating system as a whole, right. So, what are these programs? So, let us talk about this. So, first one is common hardware functions that operating system we talked about. Operating system converts the request into a set of instructions and which are then executed by hardware. So, those instructions are in a language that are understandable by the hardware. Common hardware function is the first thing. Then user interface and input output. So, as a user, when we interact with a computer, we are essentially interacting via an operating system. So, actually in a way we are interacting with the operating system. So, for that interaction operating system provides an interface. So, the interface whenever we switch on a PC and we see a operating system like Windows or Linux or Android, when we switch when we are interacting with a smartphone, right. So, there is a user interface that we see, and we see different icons, tabs and images, right. So, that user interface is also part of operating system. The operating system is providing that user interface to support users to interact with different functionality of the system. And then it also facilitates input output, because many often than not when user is interacting, user would be giving some sort of input, like when you are typing a message in an app, let us say in WhatsApp, it is you using the keypad or the touchpad there and in the smartphone and typing the message. Similarly, in case of laptop, you are using email web browser, but you would be typing your email message. So, user interface is there and the input output is there, so that the user can use that interface to interact with the operating system and applications that are there running on that operating system. For example, email application, right, and the input output goes with that, right. Then another program within operating system is API support for applications. So, where these applications are coming from? So, there are lots of software engineers which are developing these applications, but to be able to develop these applications they need to utilize the software to software interface between given by the operating system, so that their application can work seamlessly with the operating system, because the application would be vying for computing resources from the operating system. So, operating system provides a application programming interface which software engineers or software developers can use to develop their application, so that there is a seamless or smooth integration and smooth functioning between the application and the operating system, right. So, that kind of application programming interface or software to software interface is being given by the operating system for applications or to the application developer community. Then the next is memory management. So, while so many applications are there and when they run they need memory to be so that they could be executed via CPU, right. So, that memory management, especially in a multitasking scenario, becomes crucial. So, that is also supported by memory management. Then next is processing task, right. So, there are different scenarios that can be there when it comes to processing tasks. So, that we will talk about. There can be multitasking, multi-threading, and similarly other things are also there that we will be discussing. So, how operating system supports that, whether it supports multi-threading, whether it supports multitasking. For example, when we were classifying operating systems, right, single use, multi OS, distributed OS, embedded OS, then also we had this kind of discussion there, right. Then networking capability. We talked about that computers, internet and the computers might connect to other computers via that network. So, that networking capability facilitates the interaction between one computer and another computer via network. So, that networking capability is also is supported by the operating system, right. To be able to access file sitting in a different computer, that computer should provide access to those files via the network also. That means network capability, that support from the operating system is also needed. Then access and security, right. So there can be different users, number of users that could be accessing a computer and via an operating system. So operating system should make sure that users which are not authorized to certain files, they don't give access to those files, right, or unauthorized users are not able to use the computer at all. So all this access control and then security that goes with the data and programs, that also needs to be managed by the operating system. So that is another element to it. And the file management, files are being stored in the storage, right. Now again coming back to same thing, access to those files and other things are also managed by file management program within the operating system, right. And one should be able to track those files, and then whenever one is needing file, this would be it should be available to them. So file management manages that kind of part. So overall these 8 programs we can say constitute the operating system: common hardware function, user interface, input output, API support, then memory management, and the processing tasks. So anyway, task management, networking capability, right, and the access and security, and then the file management. So these are the 8 main programs within the operating systems. So when we said operating system is a set of programs, so we essentially can say these 8 programs. Then coming to these one by one. So when we say common hardware function, the first key support that operating system provides. So here the operating system is acting as an intermediary, right. So what happens here? So in terms of common hardware function, there should be support to receive inputs from the keyboard, mouse, input device. So whenever an input is coming from keyboard or mouse or any other input device, operating system should be able to receive that inputs, and then the application should be able to use that input given by the user. So retrieve data from disk. There might be files or the data which might be residing on disk. So how do we retrieve that and bring into memory? So that support also has to be there. This is again hardware function, because one hardware is disk and then it is being brought to the another hardware, that is memory. Same goes for keyboard, mouse, input device. Similarly, when you want to store data, so you might have something in the memory and you are saving that to a file in a disk. So storing data on a disk. So again it becomes a hardware function. Then sending outputs to a display, printer, or output device. So whenever some processing has happened and a output has been produced, so the operating system will send that output to a display unit or any other output device, or maybe print it out via a connected printer, right. So these are some of the common hardware function that are supported within this program, right. Receiving input from input devices, then data to and from disk, and then sending output to output devices. Moving on, user interface and input and output. So what is a user interface? The user interface is an operating system element that allows users to interact and command the computer, right. So it is through this interface that a user is interacting with the operating system, and whatever application that they want to launch or the command that they want to give based on the task, activity, application that they are working on. So user interface is the one that allows users to interact, right. Now what are different ways? So first one is command line interface, or CLI. So it is popularly known as CLI, command line interface. So what it does, it facilitates interaction by typing commands in a terminal as inputs to the computer to perform different activities, tasks, and then the outputs might also be displayed in the terminal, right. So command line interface is the original interface that was there before the more graphic based interface came around in the early 90s or late 90s in the form of Windows operating system. Some precursor to Windows operating system were also there, which started the graphical interface. So but command line interface continues to be there, and for in many computing contexts, especially when you are working with a server, right, through a terminal, and then it is the CLI interface which is very commonly used. This facilitates interaction by typing commands. So you type commands in a terminal, and that input goes to the computer which performs the actions, and the output comes back to the terminal and displayed back in the terminal. So, that is the original interface. Moving on, next is graphical user interface. So, what graphical user interface or GUI or GUI is about. So, this is the now this has become a normal interface that we have, and most of the users, whether professional or regular users, right, or the power users also, they they all of them, all category of users nowadays use or interact with some other form of GUI, right, graphical user interface. So, it facilitates interaction by pointing and clicking icons, items which might be shown in a window, and then through that pointing and clicking, essentially user can send commands which can act as an input to the computer, and therefore the application, and therefore the activities or tasks can be performed, and the output can be displayed there, right. So, the same thing you can see, facilitate interaction by pointing and clicking. So, there would be icons and items just like a window, just like this circle interface that we are using, and we can here we go and we can see this pop-up comes. So, essentially we are interacting, pointing and clicking all the time, right. So, pointing and clicking icons. So, this particular screen that you see in this video, and the interaction that I am doing, right, for example, to repeat again like this. So, this interaction that I am doing, this is a graphical user interface, right, in a window. So, we see a window, within that window we have those icons hidden there, and I could activate them and click on them, right. So, pointing and clicking, window to send commands as input to the computer to perform activity and task, and then outputs would also be shown in the window, right. So, moving on, then because there are so many new devices, computing devices that we have talked about that are there. So, handheld versus PC. Now, if we look at handhelds, the kind of interface that we have is touch and tap kind of graphical interface. So, both are graphical interface, whether we talk about handhelds or PCs, more often than not both will have a operating system which will be providing graphical user interface. In case of a handhelds nowadays, in the most recent smartphones or the tablets, they are touch and tap, and when we talk about the laptops and the desktops or workstations, many of them still remain to be point and click. So, this is both are examples of graphical user interface. Now, there are other user interface that are also there and are in development for further improvement. For example, sight and brain interfaces. So, sight interface is like where your eye is focusing on, and you record that using a camera and maybe other sensors. So, with the help of camera and sensor, use sight to activate interact with the computer. Then brain interfaces use brain waves to again interact with the computer in the sense what kind of icon or tab or item needs to be executed, right. So, sight and brain interfaces could be useful for for certain group of users who would find difficult to interact with the touch and tap or point and click kind of interfaces, right. Then the voice command interfaces. Now, this is again something that is there, continuous improvement is happening. So, this could be a future interface where certain set of voices could be mapped to certain commands, and therefore, more likely even in general purpose operating system scenario or consumer grade computing devices, we might see active usage of voice command. Already as it is happening via large language models, chatbots and ChatGPT and Gemini and other such AI apps. We are already into voice command kind of interface, but there the AI is detecting our voice command because it is able to predict the intent from what from our conversation. But here we are talking about voice command interface as part of the operating system, where we we can say open a spreadsheet and it will open that. So, that kind of interface we are talking about. Moving on, the next program is API support. So, we already talked about this one little bit, application programming interface or API. So, what this is about, this is like software to software interface, software to software interface to service requests from applications and without exposing the inner workings of the system. So, this point was left out. So, another reason for providing API is that it might not be a good idea to expose the inner workings of the system, because the programs and data you want to protect it from unauthorized access, right, because it could be misused. So, to be able to have a layer of protection, also you do not want to expose the inner working of the system for protection or security reasons, and therefore, but you do not want to stop software developers or engineers in terms of developing applications. So, you provide this software interface. So, therefore, whatever request you are getting from their applications, if they are based on the API, operating system can serve that request, right. So, many goals are fulfilled, sort of win-win situation is achieved because of the APIs. So, APIs are not unique to only operating system. So many other platforms, whether we talk about the social media platforms or the AI platforms and many other similar platforms or software products, they give their own API, and other application developers can develop small applications, other applications which integrate with these APIs and those software platforms or platform ecosystems, right. Moving on, next is memory management. So, we are already talked about the CPU and memory and the system unit. Now, here we will focus on from the OS perspective as OS perspective as in memory management as another program part of the OS. So, what are the few things that happen here? So, one thing is whenever you are doing multitasking, there are so many applications that want CPU time and you want those applications to be executed. So, the memory capacity might not be enough, right, to be able to manage all those applications that are vying for the those CPU or processing resources, right. So, there is a concept of virtual memory. So, what happens here, space on disk is allocated to supplement the immediate functional memory capacity. So, whatever memory capacity is there, along with that a virtual memory is used, which is actually a space on a disk, right. So, a space on a disk is used as a virtual memory, and because there might be memory, the primary memory there are likely to be constrained, because already few applications would be loaded in and might be running in, and if you want to start another application, right, then there might be limited memory, but you can still launch that application if you could use virtual memory. That means some space from the disk, right. So, therefore, this supports throughput, right, higher throughput, number of jobs that can run in a given time span. So, because of the virtual memory concept that is typically implemented in most OS's memory management. So, this could be supported, high throughput, more number of jobs that can run in a given time span. Then there is another concept called paging. So, what happens in paging? So, we swap programs fully or partially between memory and disk. So, when we said virtual memory, how it is being put to use. So, the concept of paging comes in, where fully or partially some of the programs will be swapped between memory and disk, and therefore, because of this paging, because of this swapping that can happen, virtual memory can work, and therefore, we can have higher throughput, and we can also reduce CPU idle time, right. So, CPU can be better utilized because of these concepts. So, this comes under memory management. Moving on, processing mechanism for tasks. So, there are multiple scenarios within this which we can discuss, right. So, one is general purpose OS. So, if we talk about general purpose OS, what is the typical objective that we have? We can prioritize throughput. So, earlier we talked about here the way memory management is being done, we are prioritizing throughput. We are not focusing on that a particular application should be executed well in time. We are focusing on the number of jobs that can be done in a given time. We are looking to maximize the throughput. So, prioritize throughput. So, general purpose operating system, the PCs, desktop laptops or smartphones that we work with, they prioritize throughput. That means how much work gets done. So, we want more work to be done, that means more tasks to be successfully executed within a time span, right. So that is prioritized. Then we also prioritize fairness. That means giving every task a turn. That means all the tasks that are being executed, they all should get CPU time. That means timely execution or timely completion of a task and application is not a priority, but in a given time span, completion of more tasks or every process getting some CPU time, some execution, some processing is happening. That means on an average level more work is being done across a number of tasks, across a number of applications. So that is the goal of a general purpose operating system. Now look at let's look at different concepts connected to it. Multi-user, so support for multiple concurrent users. So essentially when we say multiple concurrent user we are supporting, they will be running even more programs, right. So multiple concurrent users to run programs, and the same user, two different users, concurrent users can run the same program. So therefore a little bit of complexity is there, it is not so simple. So concurrent user might open the same programs. So multi-user OS should be able to support that. So earlier we talked about multi-user OS, single user OS and distributed OS. So there is complexity hidden in all those scenarios. That is why they were classified into these three different ones. So in multi-user, two same concurrent user might open the same application, that needs to be handled. So at the same times on the same computer users might want to run an application. Then multi-processing supports running a program on more than one CPU, right. So if there are more processing cores, whether that support is there, right. So operating system should be able to use multiple processing cores that are there. So some parallelization can happen because of that. So that support is also, that coordination is also being done by the operating system. Next is multitasking. So supports more than one program to run concurrently, right. So we are allowing multiple concurrent users, so in a general purpose OS, so more than one user, so more likely more than one program, right, because more users, so it is more likely that would be more than one program that might run concurrently. So that is referred as multitasking. Then multi-threading, so supports different threads of a single program to run concurrently. Now within the same application there might be certain set of instructions. So what is a thread? A set of instruction within an application that can be separately executed. So there can be multiple threads of codes or set of instructions that can actually be separately executed within a program, within an application, right. So therefore that parallelization can happen. So multi-processing, if there are more processing codes we can take advantage of that. If there can be threads, there can be set of instructions which can be separately executed. So operating system supporting for multi-threading can be a good feature here. It supports different threads of a single program to run concurrently. So you can see what are different features that can be there. So not all of these features might be there in all operating system, but in many of them would be there nowadays. So multi-user, that means multiple concurrent user, multi-processing, that means more than one CPU, multitasking, that more than one program, multi-threading, that means multiple threads within an application from the same application that can be supported. So this is about general purpose OS. Now extending that to real time OS. Now some of the things that we talked about, some of these things might also be there in the real time OS, but at a technical level real time OS are different from general purpose OS, right, because as the name is suggesting, real time is the real time response to an application or request that is expected, right, which is not the case with the general purpose OS we talked about. It prioritizes throughput and fairness. That means how much work gets done. You want to do more, throughput should be more, and fairness, every task should get it done. So but here what do we prioritize? We prioritize determinism, that means guaranteeing that a task finishes on time, right. So within the time span, within the exact time that we want it to finish, we want to guarantee that a task will finish on time. And this is a real time, so response to input should be instantly. So input comes, immediate response to that input is actually given by the or handled by the real time operating system. That is very different from general purpose operating system, because there even if the input is coming, the CPU is busy with some other task and there might be delay in terms of responding to that input. So, general purpose operating system, real time operating system, hope you are able to see the difference. And then how this is done. So, RTO as task scheduler is different here. So, what it does, it in the case of RTOS, a task scheduler can interrupt any task anytime during its execution, which is not the case in general purpose operating system, because the throughput is prioritized and the fairness is prioritized, right. So, it will not be fair to interrupt a task which is about to complete, but here you can interrupt a task which is about to complete, right. So, it interrupts any task at any time during execution to handle. Why you would like to do that? To handle an urgent event. Some higher priority task has come, some urgent event has come, because this is a real time OS. So, you need to respond to input instantly. So, RTOS, a real time operating system, will prioritize the urgent event, prioritize the higher priority event, higher priority task, and therefore, that current task might be interrupted in favor of the urgent event, right. So, overall real time, therefore, operating system will behave very differently to general purpose operating system. Next is networking capability. So, supports computers to network with other devices for sending and receiving data, right. So, that they can act the input or send output, right. Sharing computing resources. So, this networking capability will support, for example, you want to access a file which is stored on another computer. So, if that particular file is shared through the network, you can access that file and copy it back to your own disk, right. So, who is providing that support? This network capability that is part of the operating system that is handling that module is handling this aspect. Moving on, access and security. So, then security mechanisms you want to protect from unauthorized access to the user's data and programs. This is important, including there could be sensitive data. So, security mechanisms are in place so that users have access to only the data they have been authorized to, and so different users might be authorized to different parts or portions of the data or disk, right. So, that is managed by security, and then there is a logon procedure also where username and password is given so that operating system can manage different users and record who is using the system and for how long. So, if the username and password is there, only then this mechanism can be managed by the operating system. So, then controlling users access to system resources, which user has higher access or which user has restricted access to files, data and programs. So, that is also can be controlled when there is a username password. So, logon procedure is connected to the kind of access control that we want to give to different types of users. Then file management is there, the final one. So, here we should be able to track each file, where it is stored, who can access it, right. So, again this is again connected to the logon procedure and all that, but here in the file management focus is on the file, but it is at the file level this access is to be managed. So, logon procedure will have the data in terms of users and their access, but then it would be applied to files. So, it will come under file management also. So, track where each file is stored. So, this is the main thing, where each file is, so that when it is needed it is available. So, who can access and where it is available when needed, right. And also unauthorized users, we want to protect the access from unauthorized users, right. So, users who do not have the account, they should not be able to access, right. Then there can be centrally located disk, right. So, support for those shared disk or shared folders, or there can be a shared network drive. So, that support and access will also needs to be managed by the file management or needs to be supported by the file management. So, we will stop at this point and we will continue our discussion in the next session. Thank you.